Okay. We are looking at the rest of 9.1 today, so we're gonna finish this side and we're gonna go maybe another side and a half on the other page. So finish 9.1, 9.1, and we'll have the homework for next class, which is not tomorrow, it's Thursday. Hi. It's right. What's this one to us? Nope. Let's read that one. So we're gonna get on number 31. Quick reminder on what we were just talking about before we left yesterday. We talked about the difference between arranging in a line or a row versus being in a circle. So remember, a circle, since there's no real start and end, we do n-1 to kind of account for that strange behavior. And if we just were in a line or a row or straight, then we are going to call that n-1. So just however many items factorial. I feel like I said that wrong. It's just n factorial, and then in a circle, it's n-1 factorial. The next thing we talked about was the fact that we could have a reflection. So I had held up my little like lanyard, but I also like to think about it just as my hand. A necklace, a bracelet, a keychain, a key ring, something like that. Anything along those lines that you can pick up and then you can flip it over. That we have to account for the fact that there's a reflection. So if you think about your hands, if you have your palm facing you, your thumb's on the left-hand side, but then if you flip your hand so that your palm is facing away, then the thumb's on the right side. I didn't physically take my thumb off my hand and move it, right? I just flipped my hand around. So because of that reflection, nothing actually changed place. I just can hold it and move it. So we have to account for that reflection. So we're going to do that with these next couple examples. We've got the fact that we're making some bracelets or some necklaces. Number 31 says, how many necklaces can be made from one blue, one yellow, one green, one orange, one pink, and one purple bead? Okay, first off, how many total objects are we arranging? How many? 6. Very good. So we've got 6 total beads. So we're going to use that. And then my distinction comes between having a clasp or not having a clasp. Why is that important? What is the difference?
Because if it has a clasp, it has like, there's like a starting and ending point. When there's no clasp, then there's like really no starting or ending.
If it's no clasp, it's just a circle, right? So if it has no clasp, we can think of that as just being a circle shape. No start, no end, it just stays in that circle. But when you have a clasp, you can undo it and you can pull it out in a line and hold it straight. So there would be a beginning and an end. So we'll say, I'll say line, not no circle. Now, so when we do this, if we say we have 6 total beads, do we have any repeats in these beads? Anything we got to be aware of and divide off? Nope. So if I'm just putting these beads in order in a line or a necklace without a clasp, what would that be? 6 factorial. Awesome. Now we are going to have to divide. We're going to divide the fact that it's a reflection. So we're going to divide by 2 to take into consideration that it's reflection. It's reflecting, and we can't have half of those options. And you can put that in your calculator, or you can leave it like that. That's totally fine. Ava, did you put it in yours?
It's 360.
360, good. So if you left it as 6 factorial over 2, that's okay. If you made it 360, that's also okay. Just make sure to show me enough work so I know what you're doing. Now, how is that different from if the necklace has no clasp? What's my response going to be there?
It would be 6 minus 1, which would the factorial of that number, which is just 5. So 5 factorial. And then you divide by 2.
Good. So just 5 factorial over 2. And I'm just going to leave it like that. Again, if it makes you happy, put in your calculator. If not, you can leave it as is. Okay, we're going to do the same idea with 32, but this time there are 2 blue beads, 3 yellow, 1 green, 4 orange, 1 pink, 1 purple. And the beads of each color look alike. That means if everything else is the same, but I just switch my 2 of my blue beads, that would not look any different. So we're going to have to keep that in consideration. All right, no clasp, what does that mean again? Circle or line? Line, clasp means. Oh,
or no, the clasp is the line.
Clasp is a line. Good.
Sorry, I switched those.
Switch those.
Circle.
Good. No clasp is circle, which means clasp is a line. Good. And that's why I label it, because it's really easy now that I'll just kind of follow along. Okay, now how many total beads do we have? 2. 12 total. Okay, so if I've got the no clasp, I'm going to put them in a circle. what would my numerator of this be? What would my top factorial be?
11.
11. Good. Now we have to take into consideration not just the reflection, but the repetitions as well. What do we do to get to note that there's a reflection? What am I going to divide by for the reflection?
We're gonna divide by the B factorial
That's not for the reflection,
or
just the reflection. If I'm just flipping it.
2.
2. Good. Now is the repetitions or repeats. So where are the repeats? What am I gonna have to divide off to take care of the repeats?
3 factorial, 4 factorial, and 2.
Good. 3 factorial is my yellow. 4 factorial is my orange. And then 2 factorial is my blue. And nothing else repeats, so we don't have to worry about the green or the pink or the purple. And I'm actually okay just leaving it like this. 11 factorial divided by 2 times 3 factorial times 4 factorial times 2 factorial. Okay, what about the clasp if it has a line? How will that look different than what we just wrote?
It'd be 11 factorial then divided by divided by 2, and then is it the order doesn't matter?
On the bottom? No, it doesn't. Are we gonna divide by all the repeats again?
It doesn't.
It doesn't matter if we divide them. There's just one small thing that's different between these two problems. Ryan, what are you thinking? It's gonna be a different numerator, but I don't think it's gonna be 10 factorial. 12. Why, Michael? It's just it's n, right? So n is how many we have in total, so we're just gonna keep the 12 that we have. Yeah, and that's what you meant. And then we're gonna have all the repeats on bottom, so 3 factorial, 4 factorial, 2 factorial. Good, so it's almost the exact same thing, the only thing that changes it's 11 and 12. Those are the two different numerators. All right, 33 asks about how many ways can 6 couples be arranged in a row if each couple must sit together? Okay, if each couple must sit together, how many things are we arranging then? Not 6 people that are couples, it's still 6 couples. So there are 12 total people, but I want each couple to sit together, right? So there are 2 people that are gonna have to sit next to each other, right? And then there's another 2 people who are gonna have to sit next to each other. Essentially, we've got 6 spots for the couples. 1, 2, 3, 4, 5, 6. How many couple choices, I guess, do we have for the first spot? 6. What about for the second spot? Then 1. Good, and that's the same thing as what? 6 factorial. All right, that being said, within the couple, there's some options, right? One person can sit on the left and one person can sit on the right. So within that couple, I have 2 choices for the first spot and then 1 choice for the second spot. Same thing for 5, 4, 3, 2, 1. All of these, it's going to be 2, 1, 2, 1, 2, 1. You guys all okay with that? That's the same thing as saying 2 factorial to the what power? How many times am I doing that? 6, right? Now, that being said, remember that 2 factorial is the same thing as just 2 times 1. So we can just have it be 2 raised to the 6th power, and that's okay. So 6 factorial times 2 raised to the 6 factorial. Let's throw that in the calculator really quick. It should be. Did you do 6 factorial as well?
Oh, no.
And then is 2 to the 6, 64? Okay, perfect. So 6 factorial times 64 is a pretty big number. Ooh, 46,080. That's a lot of different ways that 12 people, 6 couples can sit. All right, let's keep going. This next one I do think is probably one of the hardest ones on this. So just kind of let's take note of it. We might need to come back and talk more about it, or there might be one like that on homework. But I do think this is probably one of the hardest arranging ones that we're gonna do. So let's kind of keep everything in our order and think it out. Okay, so the first thing it says, how many ways can we arrange 7 identical algebra books, 4 unique geometry books, and 3 identical trig books. So first thing we care about is just putting them in a row. How many total books are there that we're trying to put in this row? How many total books? 14. So 14 total, okay? If we're putting it in a row, we can just keep that as 14 factorial, right? Okay, 14 factorial. Okay. Now, that being said, they use the word identical and unique, and that was intentional, okay? So identical means that they're the same. That means we got some repetitions. So if I had these 2 exact same algebra books and everything was the same except these flipped, would my shelf look any different? No, right? If I just pulled the exact same book and switched it places, it would look the same. So we have to divide off our same or our identical books. So I'm going to divide off my algebra books by doing 7 factorial. And I'm going to divide off those identical trig books by doing 3 factorial. You guys okay with that so far? And you're welcome to throw that in the calculator. I'm just going to leave it as is. The first one I think is probably the easiest. The next 2, we're kind of grouping certain things together. So letter B says we want them to be in a row, but the books of each kind are kept together. So that means I want all my algebra together, then geometry, then trig. Or I want all my geometry and then algebra and then trig. Or I want all my trig and then my algebra and then my geometry. So you see what I'm doing there? So first thing we need to do is order the subjects, okay? How many subjects am I trying to put in order? 3. So we're going to start by saying 3 factorial. Right? Then we're going to kind of zone in on each subject. So let's think about algebra. How many algebra books are we trying to put in order? 7. So once we decide what order they go in, then algebra, there's 7 factorial ways to put all those books in order. How many for geometry? 4 factorial. And then what about for trig? 3 factorial. Okay. All of that is in my numerator. We had to deal with the subjects first, and then individually in each subject, we did the algebra books, the geometry books, the the trig books. Now, I still have to divide off any repeats. So what's still repeated here? Good, 7 and 3. So the books that have been identical this whole time, nothing's changed. They still have to be divided off because it looks like they're going to be the same. All right, and then the last type, it says in a row if only the algebra books must be kept together. Okay, that means that all of my algebra books need to be in one spot together. They're in their own, they're in the first spot. And then I can do my geometry books however I want, and I can do my trig books however I want. So I can do any 4 geometry books however I want, and all 3 of my trig books however I want. So now how many total things am I putting in order here? How many things am I putting in order if my algebra books must stay together? What was it? 8? 8. Why, Charlie? Good. So the algebra books have to be kept together. So it could be algebra right there, or it could be algebra over here, but they must all be kept together. Or it could be over here, but all of them travel together. At the end of the day, it's my 7 books. I've got 4 geometry and 3 trig, and then my algebra count is a bunch all together. So now we're going to arrange 8 things. The last thing in my numerator is the algebra books are kind of jumbled all up together. So how many ways is it to rearrange the algebra books? We've done this already. 7 factorial. And then last but not least, we got to divide off any repetitions. So what repetitions are there?
3 trig.
3 trig and are those repeats? No.
There's that.
The algebra, don't forget the algebra, the 7 factorial. I know these are kind of funky, but we're thinking about how many ways are there to rearrange, and then we always divide off my repetition. How many ways to rearrange? Divide off your repetitions. All right, the last thing in this section we are not going to do by hand. I just want you to do this in the calculator. I think that is fine. However, these are two different ways you might see this. So you could see 10p3, or you could see p with 10,3 in the parentheses. Either way is okay. I tend to use the first way, but it's good to know that. What I want you to do is take a second, make sure you know how to plug these into the calculator. I promise that will be on your next quiz. It will definitely be on the test, and it will be embarrassing if you don't know how to plug in a 10p3 or a 10c3 into the calculator. Yeah. Yep, absolutely. I will pull it up. And I believe your calculator, you're just gonna go to your math menu. And then do you see that they've got tabs at the top? The second to last one says PRB, which means probability. And if you go down, number 2 says NPR and number 3 says NCR. Somebody in my alpha this morning was like, well, how do you know which one's which? And I like kind of busted him a little bit because I was like, it tells you like whatever the problem says. If it says P, then you're gonna use P. And I know that I don't mean that meanly. I just mean like, look at what the problem says. If it uses a P, use a P. If it uses a C, use that one. So I'm gonna hit that NPR. Oops, sorry. And then your calculator should give you the option to put in a number before the P and then a number after the P. And that's what I have on mine. So I do 10 and then I scroll over and I hit 3 and then you should get a number. The big number always goes first, the small number always goes last. 720. Same thing for the C's. So for 10p3, I got 720, and for 10c3, I got 120. Doing okay so far? All right, go ahead and flip your paper over. We're now moving on to 9.2. As of this moment right now, your 9.1 homework is due next class. If we have time, we'll work on that at the end of class, okay? But we're gonna get into 9.2 to start. And I don't really need my calculator yet for 9.2. Okay, so this section is what we call binomial expansion. Remember, a binomial is a polynomial or an expression with two pieces. Bi means two. And in all of these, we're going to have something plus something else. And it's going to be raised to a power. The first couple say expand because I want to prove something. I'm going to teach you something called Pascal's triangle. Have you guys heard of that? Awesome. It's going to be a fun set. It's going to be a fun day if you've heard of it. If you haven't heard of it, even more fun because it's a new stuff. But we want to learn, or we want to use what we already know to build this triangle. So we're going to expand these out to begin with, and then I'll tell you what the pattern is that we see from it. Okay. On the first one, x plus y to the first power, that's just itself. So it's going to be x plus y. Now, as tempting as it is to say x plus y squared is x squared plus y squared, we know that's not how it works. We need to do x plus y times itself twice. So times x plus y. So you're going to need to FOIL out. So x times x is x squared, x times y is xy. Y times x is xy, and then y times y is y squared. And together it makes x squared plus 2xy plus y squared. Okay, so that's what x plus y squared is. Now to do x plus y to the third, we're gonna have to do x plus y times x plus y times x plus y. Now, let's work smarter, not harder. We just did x plus y times x plus y, correct? We got x squared plus 2xy plus y squared. So let's just take x plus y and multiply that by what we just got. Once you get that answer, we're going to multiply the new answer by another x plus y to get x plus y to the fourth. Okay, I think you guys know how to do this, so I'm just going to be quiet. I'll put my work up here. but we're gonna expand this out and then we're gonna be able to make a pattern so we never have to do this again. All right, I've got my answer for x plus y to the third up on the board. Once you have that, take this number or this big expression and multiply that by x plus y one more time. And then I think we'll have enough information to make a pattern, make some kind of assumptions out of this. It's a lot. I've got my work for x plus y to the fourth up on the board when you have yours ready. Double check yours, make sure you got what I have. Anybody have any questions yet? Everybody good so far? Okay. What is gonna happen is there's a pattern between the coefficients here as we progress down in our binomial expansion. If you notice, all of them, when we are looking at the first and the last term, all of them start with 1x and end with 1y. Same thing for the next one. My coefficient for x squared is 1, my coefficient for y squared is 1. Same thing on the next one. My coefficient for x to the third and y to the third is both 1, and same thing for x to the fourth and y to the fourth. Cool? Okay. Now, we are going to make this Pascal's triangle because I think that helps make the rest of it make sense. So I'm gonna write over off to the side Pascal's triangle. What this does is it gives coefficients in binomial expansion. Gives the coefficients in binomial expansion. So underneath that, I'm gonna draw this big triangle. And on the outside, I'm gonna label what each of these are. So the first one's gonna be x to the 0. And we've got x to the first, x squared, x to the third, x to the fourth, x to the fifth. Try and give us little like lines to kind of keep it straight. Okay. Now, anything raised to the 0 power is just what? Anything to the 0, 1. As we saw earlier, my coefficients when we just did x plus y to the first was 1 and 1. So I'm gonna have 1 and then 1. Making a little pyramid, a little triangle with our coefficients. For x to the squared, my coefficients for that were 1, then 2, then 1. You guys okay with what I'm doing so far? All right, for x to the third, it went 1, 3, 3, 1. And then the last one that we worked out went 1, 4, 6, 4, 1. Now, I don't want to multiply this craziness by x plus 4 again, bless you. And this Pascal's triangle is going to help me so that I never have to do that again. If I zoom in over here, we notice that all of them start and end with 1, okay? So that means when I get down to this x to the 5th line, I'm also going to start and end with 1. Now, the middle numbers come by adding the numbers above them, okay? I'm going to focus in up here. We'll start at the top. We'll look at 2. We get 2 by doing 1 plus 2. 1 plus 1 is 2. The two numbers above add together to equal 2. Okay, similar idea for 3. We do 1 plus 2 is 3. And then same thing with the 3 next to it. That also has a 2 and a 1, so that adds to be 3. Similarly with the line below it, this 4 comes from 1 plus 3. Where does the 6 come from? 3 plus 3. And then this 4 comes from 3 plus 1. Okay, so all of that being said, let's find the next row. Right above this was 1 and 4, so what should my next number be? 5. You guys okay with that? What about the next one? 4 plus 6 is 10. I've got another one. I've now got 6 plus 4. What's that going to be?
Still 10.
Still 10. And then the last number I need to plug in, 4 and 1, is going to be 5. And we could keep going. We could make this list. We could keep this tree going down forever. I don't have an x to the 6 or x to the 7, but I could keep going if I wanted to. And you just keep adding the 2 that are above it to get the number that you want to look at. We do not have to multiply out anymore. We're going to always use this for our coefficients. Okay, so if we're going to do x plus y to the 5th, we're going to start by putting out a 1 with a blank, plus a 5 with a blank, plus 10, plus another 10, plus another 5, plus another 1. I've got blanks because as we noticed from everything above, we've got x's and y's that we also have to deal with. But if we start by looking at our coefficients, we're at least halfway there. Are you guys okay with my coefficients? All right, let's look at my x's then. If I look at this expression right here, x to the 4th plus 4x to the 3rd, y plus 6x squared, y squared plus 4x, y to the 3rd plus y to the 4th. What is x doing as you go across the problem? Is x getting bigger or is x getting smaller? As I go across the page, x goes from to the 4th to the 3rd to the 2 to the 1. That means it's getting smaller, right? So my first term, my x term, is always going to go down as we go across the problem. It's going to start with the exponent that's given to us. So I'm going to start with x to the 5th, and then I'm going to work my way down until I'm out of x's. X to the 4th, x to the 3rd, x squared, x to the 1st. The last one is technically x to the 0. I often don't write that because sometimes my 0 gets lost and then I keep an x there and you do not want an x there. But x to the 0 is basically 1, so that's why technically there's a 0x there. Okay, Now, similarly, if I go back to this problem, what is the y doing as I go across the page this way? Is y getting bigger or smaller? It's getting bigger, right? We have 0 y's, then we've got y to the first, y to the second, y to the third, and then y to the fourth. So y, on the other hand, is going to increase as we go across this page. Technically, we're starting with y to the 0. Just like I explained for x, I often don't put him there because I don't want to get confused. But the next one is just going to be a normal y, and then a y squared, or y to the first, I guess, y squared, y to the third, y to the fourth, and then y to the fifth. And then y to the fifth. Okay, now we gotta clean it up. Now we gotta simplify. This one's pretty clean as it is, but I'm just gonna write it all in one color. If we had any coefficients like we have on the next ones, we'll see what that looks like momentarily. But this is gonna be x to the fifth plus 5, x to the fourth, y, plus 10, x to the third, y squared, plus 10, x squared, y to the third, plus 5x, y to the fourth, plus y to the fifth. That is my expanded out version of that. Now you can absolutely find this by multiplying x plus y 5 different times. I just think that's a lot more work than what we just did. Okay. I want to do one more with you, and then I want you to try one on your own. Are you good with that? Then we got 2 little ones on the next side, and then we're done for today. Okay. We're gonna do the same thing with this one. It says expand, and this time my exponent is 4. So let's go to that x to the fourth line, and we're gonna carry over these coefficients. 1, 4, 6, 4, 1. First step, always do your coefficients first. Second step is our x's. As our x goes across the page, remind me, what does it do? It's what?
The exponent gets smaller.
The exponent gets smaller, so x is going to go down as we go across the page. What's it going to start with?
Start with x.
X to the fourth, and then x to the third, and then x squared, and then x to the first, and then technically x to the 0, but that's implied, we don't need to write it. Now my second term is not just y, it's going to be negative 2y. What is its exponent going to do as I go across the page? It's going to go up, it's going to increase. I'm going to start with no y's. The first one you skip, and then the second one, you're going to do negative 2y to the first. Remember to put all of negative 2y in parentheses. And we got negative 2y squared, negative 2y to the third, and then negative 2y to the fourth. Bless you. Now our job is to clean up and multiply missing pieces. The biggest mistake I see is that when you're like simplifying one term, you guys start like adding or subtracting things. It's all multiplying, okay? So let's do it out slowly so we know what's happening. Okay. First term is just x to the fourth. Okay, x to the fourth. My next term, let me zoom in a little bit. My 4 is going to be fine. My x to the third is going to be fine. But I need to remember that my negative 2y, everything gets the x or the exponent. So I'm going to say times negative 2 times y. That means I'm going to do 4 times negative 2 to get negative 8. And then my variables just kind of like line up behind it. X to the third times y. Okay. Next one, I'm going to do 6 times x squared. Don't forget to give negative 2 squared, so that becomes 4. And then y also gets squared, so that's y squared. So in this next term, I'm going to do 6 times 4, which is 24. And then my little variables just get in line behind. X squared, y squared. Who's hanging out with us so far? Okay. Same thing for the next one. I've got 4. My x is just to the first, so that's a normal x. But my negative 2 gets to the third, gets cubed, so that becomes -8, and then y also gets cubed, so that's y to the third. And so I'm gonna multiply 4 times -8 to get -32 here. And then my x and my y to the third are just gonna fall in line. And then last, I need to raise to the fourth power -2 and y. -2 to the fourth, is that 16? Yeah, I think so. And then it's positive because anything to a positive or to an even exponent is gonna stay positive, and then it'll be y to the fourth, so plus 16 y to the fourth. Whew. I know you might be like, wow, it doesn't feel like a lot less work than what I wanted it to be. It's still a little bit of work, but it is much easier than doing x minus 2y times itself 4 times. Do you think you can try the next one without me? Okay, remember, do your coefficients, do your x's, do your y's, and then I'll talk. All right, I'm gonna start mine now if you wanna join me. Okay, I've got my answer on the board. Go ahead and make sure that you checked yours. Is everyone good with that? Again, I think the more we do this with this, the easier it becomes. I also want to remind you, these are multiply, multiply, multiply. Multiply, multiply, multiply. Do not add them, do not subtract them. Multiply, 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 multiply. Multiply. Okay. I know it's annoying. That's how it should be. It should be that. Okay. The last two we're going to do today, it says find the fourth term and then find the third term. This time though, my exponents are significantly bigger. It says 10 and says 7. That immediately makes me a little bit nervous, but do not fear, it's going to be okay. We don't need to do the Pascal's triangle all the way down to 10 and 11 or whatever to get those coefficients. What we're gonna do, and this is why this is in the probability unit, is we are actually gonna do a combination. It's an NCR. We're gonna do NCR in order to get the coefficient of each term. And I don't want the whole expression, I just want the third term, the fourth term, the seventh term, the first term. I do not care, I just want one of the terms. Okay, so first thing I want to think about, we're going a little bit backwards than what we did last time. Last time we found the coefficient and then we did our variables. This time we're going to do our variables first, okay? So I want to think about what is the fourth term? 1, 2, 3, 4. All right, x is doing what? What's the exponent of x doing as we go across the problem? Decreasing.
Sorry, the y is increasing.
So it starts with x to the 10th and it's going to go down 1 each time. So it's going to go x to the 9th, x to the 8th. And then on my fourth term, the one I want, it's going to be x to the 7th. Okay. Let's do our y while we're here. Our y is increasing as we go across the page. There's no y in the first term, so we've got y to the first in the second term, y squared in the third, and then y to the third in this fourth term that we want. Another hint, I don't think I've explicitly said this to you guys yet, but the exponent should always add to be whatever the total exponent is. So in this case, it's 10. 9 plus 1 is 10, right? 8 plus 2 is 10. 7 plus 3 is 10. That's one way I want you to check yourself. If you're like, oh, did I do this correctly? Do your two exponents add to be what the total was? Then yes, you did. Okay. These are my variables. So we've got x to the 7th, y to the 3rd, and my coefficient is going to come from this combination. The first number is going to be the exponent that's of everything. So it's going to be 10c. And then I don't care if you choose the number, the exponent that goes with x or the exponent that goes with y. Either one should give you the same thing. I just tend to use x because it's first. So I'm going to do 10c7. Whatever that number is going to be my coefficient for all of this. NC7. That's 120. And I just have happened on my calculator to still have my 10C3. That is also 120. So I'm trying to prove to you, you can do either the X or the Y. So my answer here is going to be 120, X to the 7th, Y to the 3rd. That's it. Now, if we have coefficients in my x's and my y's, we're going to have to deal with those, which we are on the next problem. But are we okay with what we've done so far? Notice that when we did NCR, I said you could do 7 or 3. I did not say that you could do 4, which was the number of term that you want. So I don't care what number term we want. That's not the number we do in the C. We do the exponents. That's what number I want. Can we do the next one together? All right, find your third term. I'm going to be quiet. When you think you have it, look at me. So I know my third term is going to be 2x to the 5th and then negative y to the 2nd. Why did I know it was to the 2nd? It's increasing as we go across the page. Also, 5 plus 2 is 7. We want those to match. When we do NCR in the calculator, I'm going to do what, see what. What number goes first? 7. What number goes second? Sure. What's another number that can go second besides 5? 2. Now 7C5 is going to be 21. And we need to do 2x to the 5th. So I need to do 2 to the 5th, which is 32. And I need to make sure I square that negative y, and that's just gonna become a positive y squared. So the last thing I wanna do is multiply 21 and 32. And I get 672. X to the 5th, y squared. That's my final answer. We are not assigning 9.2 homework yet. If you want to get a head start, you're welcome to, but 9.1 is due next class, which is not tomorrow, it's Thursday. Okay, I thought this was a good stopping point for today.